Hey everyone, in this video we're going to continue with our turn in place. We're going to get animations pulled into our project and we are going to get them playing and get our character turning as we move the camera. I'm going to be doing a very basic implementation of this because I want to keep this series focused on distance matching, and turn in place by the time we're through with it is going to take up 3 videos in the series. This isn't actually the last video. I'm actually going to be doing another one where we're going to work to back out the orientation warping with the turning in place when we stop using orientation warping with an idle, so that we're still orientation warped for right or left or somewhere in between that's not forward. And so without further ado, let's just get straight into it. Hey everyone, I've actually started out this video in the Advanced Locomotion project because we're going to be using a couple of animations from it. We're going to be using ALS in Rotate R90 and ALS in Rotate L90. You can get to them through this file path inside the project, and you can use any version of the Advanced Locomotion system, Blueprint, C++, replicated one, because we just need these two animations here, so I'm going to select both of them, right click, and what I'm going to do here is I'm going to go to Asset Actions and I'm going to migrate them. And migrating an asset is a way to copy and paste it from one project to another. I'm just going to select OK, and I already am navigated to my distance matching project here, so you just want to find your content folder, go inside it, and select folder, and you should get this message that says content migration completed successfully, and that's all we need out of this project. I'm going to close out of it. So we're going to navigate through character assets, mannequin skeleton, animation examples, base, turn in place, and I have these two animations, and you can see that it also brought through the advanced locomotion system, skeleton, and mesh. And if I bring this over, we can see that it's not using the right mesh or skeleton, so we need to retarget these, and we can do that fairly simply. But first we have to set up our mannequin to be retargeted to. The ALS skeleton is already set up, and it's a simple process for the standard Unreal Engine mannequin. We can just, to get there fast, we can just click on our character, click on their skeletal mesh on the side, go over to their skeleton, and open up the retarget manager by clicking here. In a default project, it'll be set to none. The select rig will be set to none. You want to choose select humanoid rig and then save. This isn't the first time I've tried recording this video. I'm going back to re-record it now, and that's why the humanoid rig was already selected. I forgot to undo that. So with that done, we can close out of both of these. We don't need this open either. And now we can select both of our animations, right click, retarget anim assets, duplicate anim assets, and retarget. We'll select our mannequin skeleton and click retarget. And now we have our two animations retargeted to our mannequin skeleton. So now that we have our animations in, I want to briefly discuss how we're going to do this turn in place system. I'm borrowing from Epic with a lot of the system. I'm pulling straight from one of their live streams they did a couple years back, and there's really a whole lot of different ways to approach turn in place, but this is a relatively simple way, and I don't want to go do too much with it here because it's already going to be 3 videos, and I want to try to keep the focus of this series on distance matching. And so in the future I might do more content on the channel about turn in place, but for now I'm just trying to keep things simple. And the approach we're going to be using is we're going to be using the root rotation in these animations because they actually have rotation if you uncheck force root lock. We want to keep that checked for now, but we can actually modify an anim modifier to get that root rotation as a curve and then use that to drive the unrotation of the root bone and unrotate the rotate root bone node by subtracting the rotation in the animation per frame from the root yaw offset value. And we'll do the logic for getting the animation playing inside the anim graph, and then we'll just get curve value while the animation is playing and use that to subtract. But we need a curve value to get first, and to do that, we're going to duplicate a modifier. Let's go into, where is it? Distance matching, blueprints, and the modifiers. I'm just going to right click start, select duplicate, and I will replace start with turn. And now we only have to make a very simple edit to this and a modifier. We're just getting rid of vector length, splitting the struct pin for pose rotation, and plugging yaw into value. Actually, we are getting the absolute value of yaw and plugging that into value. We don't care about whether it's a right or left animation. We just care about the amount of rotation in this curve. So I'm going to compile and save and close out of that. And I'll add this BPAM distance curve turn to our turning animation. I'll apply it. We have our distance curve. I'm going to open up our other animation, and I'm going to do the same thing. So now I'm going to make sure that both of these are saved. And I'm going to head back over into the animation blueprint. Now the first thing I want to do is right now, I want to make sure that the root yaw offset is on a scale of negative 180 to 180 at all times. I don't want anything that above 180 coming into play on a 0 to 360 scale. And so just to be extra safe, I'm going to get a normalize axis. And I'm going to plug this in just because it's easier to say, okay, if root yaw offset is negative, we need to turn one way, and if it's positive, we need to turn another way, than it is to say, okay, on a scale of 0 to 180, we're turning this way, and on 180 to 360, it just keeps things simpler and a bit easier to understand. And there's not a case where it's going to try to unrotate or rotate more than 180 degrees. So that won't have any effect on the turn in place. I mean, the root yaw offset, it still works just fine, exactly how it did before. Next, I'm going to set up some of the logic for our anim graph. So we're going to set up some new stuff inside of the idle state, inside of each of our directional states. So we're going to go into forward, into idle, and I'm going to cut to this evaluate in run start f anim out. And I'm going to create a new state machine. And I'm going to name the state machine idle and turn. I'm going to plug that into our output animation pose. I'm going to go into it, and I'm going to create two states. One is going to be idle, and the other is going to be turn. Each will have a transition going back into the other. Idle to turn, the duration will be 0.03. Turn to idle, for now we'll leave it at 0.2. We might do some, might try and putting some different values, see what the results are down the line. But for turn back to idle, we want to check automatic rule based on sequence player and state, because that's just saying if the if the animation is complete in turn, go back to idle. And now, while I'm thinking about it, go back into your idle state, select the idle and turn state machine, and make sure the max transitions per frame is set to 1. Now, back inside idle and turn, we can set up our logic for going from idle to turn. I'm just referencing my animation graph in my project where I work on this stuff ahead of time so that I know what's for the next video. And I can't remember my logic off the top of my head. Alright, here it is. So, we're getting the root yaw offset. I'm going to get the absolute value of the root yaw offset. And if it is greater than 90, we'll turn. And remember, this system is simple. You can always, there's different ways to approach this, and in the future, when I do a series on Locomotion Unreal Engine 5, much later on, I will cover turn in place and different ways to do it much more extensively than I am here. But right now, turning in place is not the main focus of this series, so I don't want to spend too much time lingering on it. So inside of our turn state, I'm going to get root yaw offset, and if it is greater than 0, well, I'm just going to pull out this result boolean and use it to get a blend poses by bool. And so if it is greater than 0, we're going to play ALS in rotate L90. And if that is false, we'll play ALS in rotate R90. I'll leave the blend times at their default for the time being, and I'm going to uncheck loop animation on each of these. And now, let's see, if we turn the camera 90 degrees, we play our turning animation. And next we just want to back out to the yaw offset on the root. And we also need to go into idle and paste in our evaluate run start f anim. So I'm going to compile and save, just save my progress, and I'm going to copy this idle and turn, and I'm going to replace the idle state in all of our other directions with it. To be more clear, I'm going to replace the evaluate in run start f anim node inside of all of our idle states with our new idle and turn state. Now I'm going to go back to our event graph, and I'm going to start our logic off of this set root yaw offset, because we have this branch back here. It's saying, okay, do this stuff if we're standing still. Well, we're rotating when we're standing still. We're turning in place when we're standing still. And we're further changing the root yaw offset, so we want to do it after that. So this is just the easiest place to do it from. I could go in and do sequences up here and do some more branches, but that's just extra work when we can go straight off of this node. So for this, we are going to need some new variables. We're going to need a variable called, let's see, turning, and it will be a boolean. Going to duplicate it and do a variable called has turned. And now we need a new variable that is a float, and it will be called turning curve value. And I'm going to duplicate it, and we are also going to get a or make a turning curve value last tick float. And now, off of our root yaw offset, I'm going to get a branch. And with this branch, I want to say, are we turning? There are different ways to do it. We could duplicate our logic and say, if the absolute value of root yaw offset is greater than 90, we turn. But I'm going to do something a bit different. I'm going to open up our animations, and I'm going to create a new metadata curve. I already have this turning in place metadata because this isn't the first time I recorded this video, as I've said before. I forgot to record the audio last time, so I'm back re-recording it here. And so you can just go to add metadata, create new, and name the new metadata turning in place. I'm just going to select turning in place from the available names because I've already done this before. It'll create a metadata curve. It's just a constant value of 1, and it's used to say, okay, this curve value is 1 if a certain animation is being played, or there's different ways to use it, but it's definitely a useful thing to make use of. And so I'm also going to add that same metadata to our other turning in place animation. I'm going to go to File, Save All, close out of our animation sequencer tab, and now off of the, well, condition on this branch, I'm going to get nearly equal. Actually, we can just use equal here. So we want an equal float. The bottom number is set to 1, and drag off from the top and get a get curve value from it. And so the curve name will be, and I've already forgot the name of the metadata, turning in place. So the curve name will be turning in place. So if turning in place is equal to 1, then we'll go off of true and do what we want to do when we are playing a turning animation. So what we want to do is we want to get the curve value again of the distance curve in our turning animation and subtract the change in distance curve over frame from the root yaw offset, and then set the root yaw offset with the result of that, very similar to what we do right here with yaw last tick. And so off of true, I'm going to get a sequence. And the first thing I want to do on this sequence, because it's important, I want to get a do once. The reset will be plugged into the false on our branch, and completed, we're going to set turning curve value. And I'll explain why in a moment, and we're also going to set turning. Turning is just going to be set to true from the node. We're going to plug something into turning curve value. So the reason we're doing this is because on the first frame, there is no turning curve value last frame. So we're just setting turning curve value normally. Alright, so we're going to get a get curve value. I'm going to plug that into turning curve value here. Curve name will be distance. And then the then one of the sequence is we're going to set turning curve value last tick. This is the exact same thing we did with distance and with our yaw. So we're going to set turning curve value last tick with turning curve value. And then we're going to set turning curve value with our get curve value. Now, we can drag out from our execution node, our execution pin, with our set turning curve value, and we can set root yaw offset. And I'm going to set root yaw offset with the, I was gonna work our way backwards, but it'll be easier to understand if I work our way forward. So we're gonna get turning curve value last tick and turning curve value. We're going to get the difference between those. So and then we are going to multiply that, because we don't know if we're turning right or left. The curve doesn't tell us, by root yaw offset. Well, by a select float, actually. And our boolean for pick A will be the result of a float greater than float, with the bottom set to 0 and the top being root yaw offset. So if root yaw offset is greater than 0, we're going to select -1. Otherwise, we're going to select 1. The result of that multiplication is going to be subtracted from root yaw offset. and that'll be used to set our new root yaw offset. If I compile and save, if we're just in our regular idle pose, things are working pretty well. But if we are in an orientation warp position, we rotate around, but we don't back out of orientation warping, and I think that we could leave it like this, but I think it looks a bit strange. You probably end up facing forward and not looking to the side like this when you turn. And so that is actually going to be the topic of the next video, and that's where this turning boolean comes into play. We don't really need it yet. This video is 22 minutes as of recording without me cutting any bloopers or mistakes out, and so I'm going to separate this one video out into two, and I'll see you all in a couple of days with the next video, and that will finish up turn in place, where we'll fully back out our orientation offset. Hey everyone, I hope you enjoyed the video. The next one will be out in 2 days on Monday, and I'll see you all then when we will finally finish up with turn in place. Thank you for watching. If you enjoyed the video, be sure to like it and subscribe to the channel. Hit that notification bell too. I'll see you in the next video, and thank you for watching.